Hey guys, welcome back. So you guys have 5 lessons this week. We are kind of going to go through a couple lessons within one video, but you're only going to have practice problems for the one lesson because everything kind of just ties together. So we're just doing it one big video for that, but you will only have one set of practice problems. So you have 5 sets of practice problems for me this week. The first being for lesson 9, which is what we're going to be looking at here. And don't forget you have those video keyword submissions, so make sure you're doing those. They're a nice, easy 10 points for you, so don't forget to do them. All right, we'll go ahead and jump right into lesson 9. So what we're looking at here is still more with probabilities. So the other day we wrote sample spaces for spinning each of these spinners once. So remember, sample space for this first one is red, green, blue, and white. Sample space for this one is 1, 2, 3, 4, 5. It's just all the possible values within there. And so for what is the probability of getting a green and a 3? So if we spin both of these spinners, what's the probability that we're going to get a green and we're going to get a 3? Well, first of all, how many possible outcomes do we have? Remember, here we have 4, and here we have 5. So 4 times 5 is 20. So we know it's going to be something out of 20. And how many times are we going to have a green and a 3 both happen on this? Well, that's only going to happen once. We only have one green. We only have one 3. So it's a 1 out of 20 probability. There's only one outcome out of all of that. If we list out all the outcomes, there's only one that fits both the green and 3. So it's a 5% probability. So 1 out of 20 or 5%. All right, the next one. What about getting a blue and any odd number? So first of all, we have to think about, okay, how many odd numbers are there over here? So how many would we have with odd? Well, we've got 1, 3, and 5. So there's 3 different odd numbers, and we have our blue. So we can have a blue 1, we can have a blue 3, we can have a blue 5. So that's 3 out of, well, we're looking at the same sample space, so it's 3 out of 20. Ooh, falling board. Or if we look at that in terms of a percentage, it'd be 15%. So remember, finding percentages, you're just going to take the 3 and then divide it by the 20 and then move your decimal place twice. You can do that on a calculator. I'm perfectly happy to let you do that. For number 3, any color other than red and any number other than 2. That's supposed to say 2. It got erased. So we don't want to have any reds, so red is gone, and we don't want to have 2. So we've got 3 possibilities here, and we've got 4 possibilities here. 3 times 4 is 12, so we have a 12 out of 20 probability, which is 60%. So this is all about looking at those outcomes. So writing out the sample space might be helpful to you if you can't figure it out right off the bat. By all means, list out that sample space and see, okay, how many total outcomes are there? How many of them fit the criteria that we're looking at? So these are combined probabilities, and combined probability is your key word for this lesson. So combined probability. All right, we've got a few more problems to take a look at. So the other day we looked at a list, table, and tree that showed the sample space of rolling a number cube and flipping a coin. So what's the probability of getting tails and a 6? Well, first of all, how many possibilities do we have by rolling a number cube? We've got 6. And how many do we have when we flip a coin? 2, heads or tails. So 6 times 2 is 12, so we know this is going to be out of 12 because that's the total possible outcomes. Well, how many times are we going to get a tails with a 6? There's only one outcome that'll happen like that. So it's 1/12. All right, for B, what is the probability of getting heads and an odd number? So now we're looking at heads and an odd number. Once again, we know it's going to be out of 12 because all of these outcomes here with this sample are going to be out of 12 because there's a 12 possible. How many odd numbers are there on a number cube? Well, we've got 1. It is odd, right? Yeah. We've got 1, we've got 3, and we've got 5. So once again, we have 3 odd numbers within here. So there'll be 3 out of 12 for our probability, or a 1/4. So 25%. All right, number 2. Suppose you roll 2 number cubes. So now we're looking at 2 number cubes. What is the probability of getting both cubes showing the same number? So first of all, we have to think about what is the total possible number of outcomes we have. Well, each number cube is going to be 6, so 6 times 6 is 36. And in order for it to show the same number, now it doesn't specify, so that means we could have 1 and 1, we could have 2 and 2, we could have 3 and 3, 4 and 4, 5 and 5, 6 and 6. So that means we have 6 possible outcomes. So it's a 6 out of 36, or a 1/6 probability. All right, for B, exactly 1 cube showing an even number. So we have to have 1 cube that shows an even number. So we've got 2, 4, and 6. So we've got 3 there. So we've got the 3 for the first cube, because this is the first cube. We've got 3 even numbers. But the second cube, it doesn't matter what it is. It could be even, it could be odd. So that means we have all 6 possibilities. So 3 times 6 is 18. So our answer is going to be 18 out of 36, or 1/2 chance probability, because it says exactly 1 cube. So that means only the 1 cube has to have an even number, but they could both have the even number. Okay? All right. A few more questions on that one with our combined probabilities. Remember, that's your key word, combined probability. All right, for C, at least 1 cube showing an even number. So in this case, it can be both cubes are showing it, so it's at least 1 cube. So if we think about it, how many odd numbers are there on a cube? Well, 1, 3, 5. There are just 3, and it's on both. So let's see. We have to have at least 1 cube showing the even number. So we've got the 3. Hang on. So we've got 3 possibilities here times the 6, because then it'd be at least 1 cube showing an even. But then we have the other cube and also times 6. So, but we have an overlap in there. And our probability is going to end up being a 27 out of 36. So for this one, writing out our sample space and seeing that chances of having at least 1 cube showing an even number is extremely beneficial, because we can see the 1 and 1, the 1 and 2, the 1 and 3, the 1 and 4, the 1 and 5, 1 and 6, 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6, 3 and 1, 3 and 2, 3 and 3, 3 and 4, 3 and 5, 3 and 6, so on and so forth. And we could see, so we've got at least 1 here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So just in these first 3, we have 12 already. So going through and looking at those probabilities there. So having that sample space all wrote out for rolling each of these number dice is very beneficial in finding the 27/36. All right, for D, 2 values that have a sum of 8. So in this case, we have to think about things that add to give us 8. So we know 2 and 6 will give us 8. So we've got 2 and 6 as a possibility. We have 3 and 5. We have 4 and 4. we have 5 and 3, and we have 6 and 2. So each of these is one of our probabilities. So we have 1, 2, 3, 4, 5. So we've got a 5 out of 36 chance. So yes, it does matter having it flipped one way and the other for that. For E, 2 values that have a sum of 13. Now, take a minute to think about this. If we have 2 number dice, the highest they go each is 6. 6 plus 6 is what? 12. So can we ever add anything to get to 13? Nope. So our probability is 0. So any time that it's just not possible for whatever the instance may be to happen, it's probability of 0 because it's not possible for it to happen. All right, and the last one. Jada flips 3 quarters. What is the probability that all 3 will land showing the same side? So we've got 3 quarters. They each have 2 possibilities. So we've got 2 times 2 times 2. So 2 times 2 times 2 is 8. So it's out of 8 possibilities. And so what's the probability that all 3 will land showing the same side? So we're either going to have all heads or all tails. So that's 2 out of the 8. So what we've been looking at through this is our combined probabilities, like I said. So we have more than one thing happening. We can't just focus on, we flip the coin once, what's the probability? We have to focus on all the different possibilities and the fact that, okay, we flipped the first coin, we got heads. We flipped the second coin, now we have tails, so there's not a pairing. We flipped the third coin, we went back to heads. So having those sample spaces and remembering how to take and write out those sample spaces will be very beneficial for you guys. All right, so like I said, you do have 5 sets of practice problems this week for me. This is the first one in lesson 9. Have a wonderful week and happy mathing.